Hello everyone and welcome back to DSP Learning Series. In today's video, we are going to explore an important and interesting operation in digital signal processing, that is multiplication of two signals. Signal multiplication is widely used in applications such as modulation, signal mixing, communication, then digital signal analysis. So here we will understand how two signals are multiplied sample by sample and observing the resultant signal. Using MATLAB, we'll generate two signals, perform their multiplication, and visualize both the original and the resultant waveform. So stay with me as we learn this concept step by step in a simple and practical way. Here we will be taking two input signals. The first signal is x1 of n is equal to sine of 0.2 pi n. Second signal is x2 of n is equal to cos of 0.2 pi n. So here we are multiplying the two signals x1 of n and x2 of n to get the output y of n. The mathematical expression is y of n is equal to x of n into x2 of n. So y of n is what? It is x1 of n, that is sine of 0.2 pi n into x2 of n is cos of 0.2 pi n. Now here we'll use the trigonometric identity 2 sine a cos a is equal to sine 2a, and we'll get y of n is equal to 1 by 2 sine of 0.4 pi n. Okay. So here amplitude of y of n is half, that is plus or minus 0.5 of the input sine wave. Then frequency of yn will be twice that of the input sine wave, and the output is a sine wave with amplitude scaling and frequency doubling. Now here this is the graphical representation. This is the input signal, that is x1 of n. This is the output second input signal, that is x2 of n. These two will be multiplying to get y of n, that is 1 by 2 sine of 0.4 pi n. And the applications of the multiplication of two signals are, this is used in communication system, that is it is used in the modulation and demodulation of the amplitude modulation, then DSPSC, that is the double sideband suppressed carrier, and many more. Then it can be used in image processing, that is it is used for pixel wise multiplication for masking, blending and filtering. And here it is also used for amplitude scaling, where it is used to scale the amplitude of the signals. Then it is also used in filtering and analysis, that is it is used in frequency domain filtering and the signal analysis. So this is the MATLAB program where we will take x1 of n, x2 of n, we'll create the time index, then we'll multiply both, okay, that is element wise multiplication, then we'll plot it. So here multiplication of two signals results in a new signal whose amplitude and frequency are what? Whose amplitude and frequency are changed, and it is simple and also powerful with wide applications in DSP and engineering. One thing here you have to remember is the amplitude also gets changed and the frequency also gets changed. So here this is the graphical representation. Okay. So this is x1 of n, this is x2 of n, and this is y of n. Now this is the program. So here as usual the program starts with the three basic commands, that is the CLC, which clears the command window, clear all, which removes all variables from the workspace, and close all, it closes all the open figure windows. So these commands ensure that the program starts with a clean environment. Then second, that is the next line, it is the time index, that is creating the time index. N is equal to minus 10 colon 10. It will create a discrete time index ranging from minus 10 to plus 10. And the signal here, it contains how many samples? It contains 21 samples from minus 10 to plus 10. And this time index is used as the x-axis for plotting the signals. Now step 3, or the next step, this was the first, this is the second. Now third step is you have to generate the first signal. So for first signal we are taking x1 is equal to sine of 0.2 into pi into n. So here it will generate the first discrete time sinusoidal signal. And here the MATLAB will compute the sine value at each sample of n. Then next step is generating the second signal. that is x2 is equal to cos of 0.2 into pi into n. So here it will compute the cosine value corresponding to each sample of n. Now next step is multiplication of the two signals. So here we are using the operator which will perform the element by element multiplication. So here each sample of x1 is multiplied by the corresponding sample of x2. Okay, so here the resulting signal will be the half the amplitude of the and it will be the double the frequency. Okay, next here we have to create the first subplot. That is you have to divide the figure into 3 rows and 1 column, and you have to select the first subplot for plotting the first signal. Okay, this one. Then so here you have the stem n comma x1 comma filled. So here it will display the discrete time signal. Then filled fills the circular markers, and title will give the plot title. Here you have no title A, that is the first signal x1 of n. Next you have to label the x-axis and you have to label the y-axis, and here we are using the grid to display the grid lines. Similarly you have to say plot the second signal. Okay, this is for the second signal, that is the second input signal. After that, this is to plot the multiplication of the two signal, that is the multiplied signal will be plotted here. Okay, so here this will display the product of the two signals, and each output sample it is obtained by multiplying the corresponding samples of x1 of n and x2 of n. And here you can see the graph. Okay, this is the graph which illustrates the change in amplitude and the frequency after the multiplication. Okay, you can see the changes in the frequency and the amplitude. So here this is the summary, that is the signals. First we are creating the time index for 21 samples, then we are taking the two signals, we are multiplying that. Okay, then this is the mathematical result, this is the graphical representation. Okay, and here this is the MATLAB implementation, and these are the key takeaways from this program. That is, multiplication of two signals is performed sample by sample, and the resulting signal has the half the amplitude and twice the frequency. And the trigonometric identities, it will help in understanding the result. Here this we are using the trigonometric identities, that is 2 sin A cos A is equal to sin 2A. And here this MATLAB, it makes it easy to generate, manipulate and visualize the signal. These are the applications which we have discussed. Okay, and here this is the graph which we will get after executing the program. Fine. Now these are the applications, that is, it is used in image masking, that is called as the filtering. It is used for brightness adjustment, that is the scaling. And also here it is used for contrast enhancement, that is the gain control. These are the applications of multiplication which are used in image processing. Okay, then you have image blending, that is the multiplicative blending, which will combine the two images to create special effects like texture mapping, shading or illumination effects. Then you have frequency domain filtering, where the image spectrum, it is multiplied by a filter to remove or enhance the certain frequencies. Then next you have the background removal. Okay, you will be using here a mask in order to remove the background, and here you will get the object of interest. Next is image gating, that is the spatial domain, where it is used to select a specific area in the spatial domain for further processing or analysis. And these are some of the practical applications. Okay, that is applications in practical systems. It is used for illumination correction, multiply by illumination map to correct uneven lighting. It is used in image compositing, alpha masking, then video processing. Okay, these are some of the applications of multiplication of two signals in the image processing. Now we'll execute the program. So here already I have opened the MATLAB and I have typed the program in the editor window. Okay, now what we'll do, we'll run it. So here this is the graph which you will get. This is the first signal, this is the second signal, and this is the output. That is the multiplication of these two signals. Okay, so hope you have understood the program, and do practice this program in MATLAB so that you get more knowledge about the execution or understanding the program here. So, and this brings us to the end of today's video on multiplication of two signals in digital signal processing. We learned how to how two discrete time signals can be multiplied sample by sample, and how MATLAB can help us generate, calculate, and visualize the resulting waveform. So this operation, it is important for it is an important foundation for understanding the advanced DSP concepts and practical communication applications such as modulation and the signal mixing. So I hope this demonstration made the concept easy to understand and useful for your learning. If you found this video helpful, please like, share, and subscribe for more interesting DSP concepts, MATLAB programs, and practical demonstrations. See you in the next video. Bye bye.